Triangle PST is equilateral, and E is the midpoint. And you can abbreviate too, guys. Okay, you don't have to write the whole word midpoint of TS. Okay, just make sure that it's like obvious what you mean when you abbreviate it. Okay. And so, how do we know, Josh, that was true? Yeah, exactly right. You're exactly right. It's given to us. That's exactly what it is. And so we're just going to write the word given. Okay? Easy to write. Okay? It is given to us. Okay. So that's the easy step. That's hopefully the step. Everyone here can get that. No problem. Now, I told you guys that we're looking for congruences, right? We're not given any congruences in the given information. But when you're given information, then, and it's not a congruence, that means we can use it to get a congruence. Okay, so Ikeva, what's up?
You would put like a line on TE and a line on ES.
Okay, how do we know that TE is congruent to ES? What gave that away?
Because E is the midpoint, so that would mean like
they're going to be equal parts. Exactly right. So TE is going to be congruent to ES, and so we can actually write that down here for a step. We know that TE must be congruent to ES, and Ikeva's reasoning, okay, how did she know it? It's because E is the midpoint, okay, of TS. Okay? That given piece of information ends up being a reason for a congruence. Okay, so this given piece of information ends up being a reason for a congruence. Okay? Now, there's another piece of given information here. Can we use it as a reason for another congruence? If we're saying triangle TSP, which I know it's not drawn to scale, please, so yeah, please, I understand it, that doesn't look that way. But if triangle TSP is equilateral, what other things can we say are congruent here? Go ahead, Jaden. Sorry? PE. Okay, so that's not using the equilateral, but PE is congruent to what? PE. Yes. Segment PE is congruent to segment PE. And Jaden, why is that true? What's the property we use that something is congruent to itself? Reflexive. Okay, reflexive property. Okay, and you can abbreviate the property as word prop, period, right? Okay. Okay, great. So let's see here. I see that's one side congruence, two side congruences. We need to come up with one more congruence, it looks like, right? Because I only have two congruences so far. I need one more to make my triangles congruent. So what else? We haven't used the fact that triangle PST is equilateral here, but if we know that triangle PST is equilateral, okay. Careful, Jason, what does equilateral mean? What is equal? What are all equal? Sides. The sides of this triangle, this big triangle here, that's made up of the two smaller ones, this big triangle, all the sides are equal. So what two sides do we want to specifically say are equal here, though?
PS and PT.
You got it. Exactly right. And I heard, Jaden, you said that too. That's good. Okay? PS and PT are the ones we want to say are congruent here. Okay? Why did we want to say those two are congruent? What can we now say?
Because they're both on the same size.
They're going to be the same size. Sorry. Yeah, what's our reason over here? What can we say? How do we know they're going to be the same size? So what piece of information do we use?
The diameter says PSP is equal.
Exactly. Triangle PST is equilateral. That's our reason that we know that those two are equal. Okay? So, right, we can see it's da-da-da. Okay? Is the statement side, side, side? Do I put the side, side, side here?
No.
What's the statement that goes here? Let me go to someone. I'm sorry, I'm going to pick someone. Okay, well, thank you for volunteering. I'm going to give Skylar. What's the statement that goes here? The last statement. And yeah, and if you're ever unsure about how to name them, you can just use the prove statement right there. It'll be right in the correct order for you. So we're going to go ahead and just do that. So then we don't have to worry about that. And then step 5, or the reason for 5 then, Skylar, was what? Okay? and we're done. That's it, okay? So again, this wasn't too bad, right? This, you can see this proof is a little bit longer. Why? Because the given information was not straight up congruences. We had to then use the given information to state our congruences. But you can still see we have our 1, 2, 3 pieces of information here, sides or angles of 3 sides or 3 angle, 3 combinations of sides and angles that make then side, 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 or in case side, angle, side. Yeah.
So let's say it says, PT is congruent to PS in the statement.
In the given?
Yeah.
Mm-hmm.
So that's a congruent.
Yes.
But would you put it as a congruence, or would you just put it as number 1?
I mean, you would state it as number 1, and it's given because and the reason is because it's given. But you can, I like to label a little S next to it just for me to kind of keep track. Like, you guys don't have to put these little S's in there,
I'm saying,
but you could.
Is it I would put it, even though it's in number 1,
Yep.
I would put it as a congruence.
It's like, once it's stated, even if it's in step 1, if a congruence is stated in step 1, it still is good. Like, it's got it. You got it now.
Say it again.
Yep. You don't need to say it again. You've got it. Because it's already been given to you. Okay? Here, I had to state these specifically because they weren't in the given. I had to then use the information. Or the picture. All right, let's move on to this next one here. Okay. Hold on. Okay. Is that good enough, Ramel? Can you see all you need to see? Equilateral, yes.
Mr. Witt, how come it has a ray? Because there's not a ray in the shape.
You're right. We'll talk about that. We'll talk about that here. Okay. All right, so let's see here. So, Maddie, first statement, what's it going to be? What's the matter? You still need to see more?
No, I'm not.
Oh, you're done? Oh, okay, thank you. I got you, okay. Yeah, and when there's a single arrow above MR, you remember what we call that? So a line would have arrows on both ends. What do we call it when we only have an arrow on the one end? You remember? Array. So it's ray MR. Okay, so ray MR. Go ahead, continue. Sorry there. Maddie. Ray MR what? Very good. Angle KMA. Is that the only given statement we have? Okay, so I'm just going to correct you just a little bit here. I think you know what you mean, but this is line segment, right? Because there's no arrows on the end there, so it's a segment MK or line segment MK. Okay, if it were a line, it would have arrows on both ends. It's the same difference. Well, I know, and for the most part, but remember, lines in geometry, they go on forever, right? Okay, and that's given to us. So in this case, we've already got one congruence. MK is congruent to MA. So that's already a pair of sides. So Ikeva, we do not need to restate this, as you were asking before. We don't have to restate it. It's there. Okay, we've got it. Okay? Now, Ikeva pointed something out here, and she's right. MR, there is no ray depicted here, right? There's no ray coming out from M through R and then continuing on like that. That's okay. We can still say, though, that this segment is going to bisect angle KMA. So this big angle here, angle KMA, is bisected by this ray MR. Okay? So let's see here. Can we pick some other congruence out? Let's go to Cordell. What do you say there, Cordell? Can we pick out some other congruence here? MR is congruent to MR? Yep, perfect. Very good. You guys are getting really good at picking out those those sides that are shared. And what would be the property here that gives us that something is congruent to itself? Reflexive, yep. Reflexive property. Okay, reflexive property. Very good.
Wait, do they have to be in order?
What do you mean, do they have to be in order?
I did KR and RA first.
Okay, do we know that KR is congruent to RA? What piece of information will be used to say that's true? Right, so we can't say that's true. But MR, Jason, right, must be congruent to MR because it's shared. It's the same thing.
Isn't it technically bisected?
Okay.
Correct.
It's bisecting, not a side, though. It's bisecting the angle. So if we bisect an angle, that means we should end up with two congruent angles, not two congruent sides, necessarily, okay? So, yeah, it is going to be a side angle side.
But
Okay.
in the proof it says K is congruent to A.
Right, but that's what we're trying to prove, so we can't assume that's true yet. You understand what I'm saying?
Well, I mean, actually...
You're putting the cart before the horse. Nope, we can't. Not if we haven't proved it yet.
It's always going to work out, though.
In these proofs, yes. But you understand, it's like you're using like circular logic. You're saying, because we're going to prove it's going to be true, then we can use it to prove that it's true. It's like kind of like you're going in a circle.
So you can't
do that.
use the proof they give you.
No, we have to use only the given information to then get to this point, using side, angle, side, angle, side, or hypotenuse leg.
This is hard, I need help.
Well, like I said, we're going to practice some more. We're not done after this one, okay? So when we have something... Oh, Taylor? So, not necessarily, no. If they're like not dependent on one another. So like for example, well, let's go ahead and make statement 3 here real quick. Okay? So we haven't used this piece of information yet, and I kind of hinted already to Ryan that if we have a segment bisecting an angle, that means we create two congruent angles. Which angles are going to be congruent here based on this being an angle bisector? If MR is an angle bisector of KMA, what two angles must be congruent here?
Oh, R and K.
So angle KMR will be congruent to what? RMA. Can you guys see that okay? Let me point it out here. So KMR, that's this angle right here, must be congruent to RMA. That's this angle right here. And that makes sense, right? If MR is an angle bisector of KMA, this big angle KMA is cut in half by MR, that means these two angles must be equal. Must be. Okay? And so that's our reason. Ray MR bisects.
What about angle K and angle A?
We don't need them.
Why not?
Because what do we now have? What congruence do we have?
Angle, side, side.
Side.
Angle, side.
Side, angle, side.
I know, but before you put those angles, I was thinking angle K and angle A would be congruent.
What would be your reasoning for that? See, that's just it. They look congruent, and in fact, they will be congruent, EK, but you're right, they will be because we're going to prove these triangles congruent. But we don't have a reason for saying they must be congruent using this given information. We have to always go from our given information and the picture.
Right, and how do you label an angle? Like, how do you know what letters converge?
So, to name, for example, this angle, okay, the vertex point, so this is a good question, guys, so make sure we're paying attention here because a lot of people have difficulty with this, right? To name this angle, for example, the vertex point, that is the pointy part of the angle, is always going to be your middle letter. So M is the middle letter. The middle letter. Okay?
How do you know what's the middle letter, though? I mean, you could say K was the middle letter.
No, because the angle, we're not talking about this angle. You understand what I'm saying? We're talking about this angle. So if we were talking about this angle, then K would be the middle letter.
Okay.
If we're talking about this one, then M must be the middle letter. Now, with that being said, then it's just a matter of figuring out, okay, well, here's one side of my angle, right? Here's one side, so K, then M for the middle letter, and then R for the other side of the angle. So KM, R, to get the rest of the angle.
So
you see it?
also do AMR.
Exactly. You also could have named this AMR as well. Yep, exactly right. Okay? So, we're finally done. And like Jason said, we're done. It's a triangle. It's a side angle side congruence here. Okay, so what's our final statement here, Taylor? What's going to be our final statement? Sorry. Shh. Triangle KMR congruent to triangle AMR. And Jaden, what's going to be our reason for that? So I put you on the spot there. Just let's go through it.
Oh, sorry.
Yep, side angle side. Okay. SAS. Okay. Questions on that? Okay, I got a lot of good questions, guys, and I know this is not easy. Okay, I know it's not. Okay, and I'm sorry that it's not easy. I wish I could make it easier. I try to make it as easy as I can. Okay, but it's tricky, different, uncomfortable. All right, so we're gonna look at some more proofs then here. All right. We're going to do some more. We're going to do different. You guys got one ready yet? Rock and roll. We're going to try some on our own here in a second, yeah, and then, but I want to go through just like one or two first, and then I'll have you guys try some on your own. So, yeah. Okay. Because I just want to get you the practice of making sure you can do that too, because sometimes you'll have to write it on your own. Okay. So you'll notice here at the top, for these, okay, so day 2, we're going to look now at angle side angle and angle angle side proofs. Okay? So, and sorry my word prove there got cut off. Okay? So what I would like you guys to do for this very first one here, okay, I want you to first mark your triangle with the given information, and then also go ahead and list out the first step there, okay? So go ahead and get your proof started, and mark the information on your picture there that you know to be true, okay? So go ahead and take a couple minutes, mark the information here from the given, and then also make your first statement there too, okay? So take like 1 or 2 minutes.
I already listed number 1, but how do you, when it says something like IJH is congruent to JHK, how do you mark that? Like, that's the entire English.
So you look again, IJH is IJH. That's this angle we're talking about right there.
So how would you mark it?
So you put a little arc,
Oh.
right? And then IJH and then JHK, you put a little arc there that matches it because they're congruent. Okay, so go ahead and mark those real quick.
I believe.
Okay. It is. It's not easy.
Are we gonna have that one today?
Yeah.
Well, we'll see. We'll probably have at least a class. Good chance to get it. Okay, so let's make sure we're getting started. You try to do the first of your group, and then mark the information that you see given there on your picture. Don't worry about that right now. Just do what I asked you to do there. We'll get to that, okay?
I mean, oh God.
So I have this, so what was my
Well, do you see anything else congruent in that picture there? Between those two triangles. Yes, you can go get a drink. Yes, go ahead. The markings aren't quite like this is good, but these are angles that should be marked. You mark some sides there, but go ahead and get your drink, and then we'll. Exactly. Yeah, you got it. Perfect. Exactly right. Well, you did it. That's what you marked it. That's correct. Like, that's your given information, so you've already got that. What's your next thing?
I'm trying to
There.
mark it with.
J-H-I, so that's J-H-I. So this is like okay. I think everyone's got that stuff started out at least, so here we go. Let's take a look. All right. So when you are marking angles, it's a little bit trickier than sides, right? Because there's 3 letters here. So let me just show you. It's real easy, though, if you just follow the path, right? So J-H-I. So J-H-I. 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 So it's this angle right here. Okay? So that is going to be congruent to H, then J, then K. H, then J, then K, H, then J, then K. So there it is right there. Okay? And then IJH for the other one. So IJH, IJH, IJH. So it's this angle. Okay? Thank you, sir. Thank you. Hold on a second. Let me give you this. Matt. That's for you. Okay, and then that's going to be congruent to JHK. So JHK, 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 JHK. It's this guy. Okay. And so our first statement, I'm not going to call him Matt, that wouldn't be very fair. Garrett, what's going to be our first statement here, buddy? I know you just got in, but you should still know. What's the first statement for every proof? Again, we're always going to go to the given, so it's just the given information. So it'll be angle JHI is congruent to what here, Garrett? Angle HJK. And then what's the other congruence that we've got? IJH is congruent to JHK. Okay? And what's our reason that we know that's true, Garrett? Because it was given. It was given to us. Okay? That's right. All right, so we have already 1, 2 congruences. We already have 2 congruences, and there's one more in here. Now, in the given information, it's kind of already been used up, and they're in congruences. So we're not going to be able to come up with the congruences from the given information because they were just congruences. But can we see in the picture here anything that must be congruent? So Zaria? Yes, exactly. Okay, so the segment here, JH, right, it must be congruent to segment JH. Okay? And Zaria, what's the reason for that? What's the property? Reflexive, you got it. I think I'm going to abbreviate it with just prop. And that's a side. Okay? So I'll draw in that congruence right there. So according to our picture here, guys, and I guess Zaria, what congruence do we have here then? Well, it's angle, side, angle. Okay? The side is between the 2 pairs of congruent angles. So you can see it's like the single arc, the side, and the double arc is congruent to the single arc, the side, and the double arc there. Okay? And so this is going to be angle, side, angle. And so we're going to, again, just say triangle HIJ is congruent to triangle JKH. Okay? And that's by angle, side, angle.
Does it matter which way you letter it?
What do you mean by which one are you talking about?
Order of the letters.
For this?
No.
For the triangles? Okay, so I always go to what's the proof there, and then they always have it in the correct order. Okay? I'll say this. So, Zaria, the way you name the first triangle doesn't matter. But the way you name the second triangle does matter. Okay? So, for example, another way I could have named this is I could have said, instead of HIJ, I could have said like triangle JIH. Okay, but if I do triangle JIH, then, so let me I'll write that here. Oh boy. JIH. So if I said triangle JIH, then what must be the first letter of my triangle over here? Well, J, okay, has to match up with angle H there. Okay, the I matches up with K, and then the other H matches up with this J here. So it has to be in that order. So you see what I'm saying? Like these points match up. Angle, this angle here, the H for this triangle has to match with the J for this triangle. So they have to be, I always just go to the prove order because it's in the right order for us anyway. So we're good with that. Yes, Ikeva.
What happens when you're given information is like line segment AD //.
All right, we'll take a look at that one, okay? It means parallel is what that symbol means.
Oh.
Okay? All right. I want you guys to go ahead and try number 2 on your own. I think you guys have enough knowledge to be able to do number 2 on your own. So go ahead, let's give that one a shot, okay? So I want to see everyone give that one a try, okay? Number 2 on your own.
Oh, you're just going, I want to make sure I'm writing this one.
Okay. So let me,
It's thing number 2.
You want to see this one?
Yeah.
Yes.
Remember to do it that ABC is equal to CDA?
Oh my gosh, and the triangles, hold on a second. Yes, you're right. Thank you. Matt, let me fix that. My triangles are misnamed. So let me say triangle MBD is congruent to triangle MCF. That should be right now. Yep, I didn't fix that. Okay, so yeah, go ahead and give that one a shot, okay? Give that one a shot, see what you come up with there.
The only thing I could do is do this.
Yep,
That's conditional.
exactly.
So that's how you write
Yep.
it. And then I would say my reason is because of this.
Yep.
Okay.
You got it, kid. Very good. Number 2, yeah. It's too much work. No thanks. I think I come on far away though.
Oh, so am I.
Something like that.
No.
Yeah.
Wouldn't MD be listed?
Or coconuts. Sorry.
Wouldn't MD be listed?
Yep. M is right there. M is ending point of DF. So that means, and don't forget that's one of your givens. So put that in your given statement too.
Trust me, if I'm coming to the pot.
Oh. Oh, I see what you're saying. So what do you want? Like, let's mark it. So how, what do you want?
Stop. Like,
So,
stop. Okay, turn your glasses. This is your glasses.
also side angles.
No. Oh, this is
I don't know. Right, but.
This is probably upside down. You feel like
Not quite. I show you why. Both sides need to have opposite one. This angle,
You know why? Because you don't pay attention. Okay, well, how do you know?
I'm not.
Okay, great. How do you know how to do that? And how do you know?
One thing
Yes. How would you label this?
1 second, I'm just gonna take care of something real quick. I apologize. All right, sorry, I have a couple questions here I gotta take care of. All right.
Hong Kong.
Okay.
I don't know what to say.
So that's why I suggest you mark your picture with your congruences, and I think it'll help you figure out what the... Well, but just go ahead and mark these congruences in, and then I'll come back and help you, okay? So show me, using congruency marks, that angle B is congruent to angle C. Like, you know, when you draw the little arcs in there. Draw the little arcs in there at angles to show they're congruent. And I'll come back and help you, okay? It'll be easier once I have that drawn. All right. Right, okay, so you didn't mark your picture. Go ahead and mark your picture. No. Diagonal. Look. Angle B. Mark it.
So this is parallel, and the only thing I can prove,
please, not on topic. Thank you. Is she helping you? All right, well.
the only way I can write it is to be able to, but I all marks are going to be consistent.
No, you're not.
It's the same thing. They're so you don't need to say it twice.
So how do I do
We
that?
talk about what's that?
I can help you. I'm going to teach you.
Where do you go?
So angle B.
Yeah, everybody's supposed to.
Does other do that? Physically teach you? He doesn't pay attention and then he's like, oh, I don't know what to do. Okay, so tell me what number
Okay. All right, Matt, what's up?
I don't know what I was asking Mr. Webb what I was supposed to do.
Okay, so you need a mark. So yeah, you mark them. Okay, good job. Good job. So you mark them with the second one.
Calm down. Wait, that's a B in that.
Our goal here is to
Beat those
No, I'm saying that you could say without that first line, you could say that this would be congruent to English, which is not true.
Oh my God.
So here we have our two apples.
Okay.
Our case is congruent to English.
I was starting that.
I can show
What is it?
All right, so now we finish up here up front, okay? Okay, woo! That was exciting. Wow. Wow. Oh, should have got Shirley. Goodness. All right. So, Evan, real quick here, I want you to do the first step here, bud. What's going to be the first step in our proof? The given, exactly right. So, all right, guys, listen up here, please, to me. I promise we'll get you a chance to look at that, okay? Okay, that is given. All right, guys, also, I saw a lot of students not doing this. When you list out congruences, please put them in your picture. It will help you, I promise, okay? So B and C are congruent. Angles are congruent. And then angle D and angle F are congruent. Okay? If B and C are congruent, I use the single arc, and then D and F, I'm going to use double arcs because I already used the single arcs to show B and C are congruent. Okay, you need to use the different, arcs depending on that. All right? All right, now, we already have those two angles. So we have an A and another angle pair. We need to come up with one more congruence to get our three-piece information. Okay? We haven't used that M is the midpoint of DF yet. So, what's that going to give us if we do that? Alicia, what else must be congruent? Yeah, okay. DM and MF, segment MF must be congruent as well, okay? How do you know that, Alicia? What told you that? Yeah, M is the midpoint. Shh, guys, noises, please. Okay? M is the midpoint of DF. Now that's a side congruence.
Why?
Why? Because it was two sides that we're marking congruent here of the triangle. Okay? Now we've got 1, 2, 3 congruences done there, and so we're ready to prove the triangle is congruent now. We're ready for our final step, which is always what we're trying to prove. Okay? So now, if I look here, is this angle side angle? Is the side between the two congruent angles here?
No.
Angle, side, angle? No. It's angle, then side. Okay? Sometimes people put side, angle, that's okay as well. I won't mark it off. But the key thing here to note is that the side is not between the two pairs of angles there. Okay? Do you see that, Zaria, the difference? I know you were unsure about that.
I wasn't sure about the thing. I was unsure about where the marks go.
Oh, the marks go. Are you okay with where the marks go now? Okay. Sorry.
They keep talking about it. They're annoying.
Yeah, guys, look. We need to stop talking right now, okay? If you have a question, Garrett, what's your question? Ask me, okay? Because right now I'm supposed to be listening. People are trying to pay attention. What's that?
He is listening.
I understand, but I want you to ask me, okay? So, because you're talking when I'm talking, other people are trying to pay attention. That's what the problem is, okay? So what's your question, Garrett?
I
It's like everybody.
Okay, good. When we're doing classwork time, it's fine to help. But when I start talking, I need you to listen, okay? Okay, so that's the time to ask me a question, all right? And not interrupt one another, because it does distract, okay? All right, let's take a look at this last one here together, and then I'm going to have you guys do some on the back there, okay? So, this picture here, okay, our given information, we've got some new information we have not tackled yet. We have not worked with parallel stuff yet, okay? And I kind of gave away what that means, right? When you see these two little lines next to each other like that, it means parallel, okay? We also have a congruence here. That's helpful. So let's go ahead and mark that in. So AD, segment AD, is parallel to segment EC. Okay, remember how do we mark parallel lines? You guys remember? It's little arrows. It's little arrows you put on them.
I said that.
Okay, or sometimes they're like little triangles too. Okay, but that's how we show they're parallel. Okay, this one's different, guys, so you really want to make sure you're paying attention for this one. If you feel like you've got it for the last couple, and you're like, oh, I cannot pay attention, this one you really want to pay attention for because it's different, okay? So please listen up. All right, we also have the congruence BD is congruent to BC. So there's BD, there's BC. Okay, so that one's pretty standard.
Wait, what is the little arrow thing for?
That means they're parallel.
What is B business?
So that, yeah, if with that known, then B is the midpoint. That's exactly right. Okay, now we're not going to necessarily need that for our proof, but that is true. That is true. Okay. All right. So now all we've got, and we'll go to our given information here. AD is parallel to EC, and BD is congruent to BC. Okay. So that's a given. Okay. So we only have one congruence, and it's a side congruence. Okay. All right. Now, before we talk about the parallel congruence, can anyone see another thing that both these triangles we must know that they are equal? Zaria, what do you say?
A and B and B and C.
Shh. Hang on. Shh. I asked Zaria, so please let Zaria speak. Go ahead.
B and A and B and C.
BA, it was like side BA
Yeah.
and side BE. So
Where's the
we can't. I mean, we know they will be congruent, but right now we don't have we can't get that from. I mean, they look maybe they're going to be the same, but we can't necessarily say they must be.
I would say the angle of A and B and C.
So A and D.
Yeah.
So these two angles must be congruent
Yeah.
to each other. Maybe, not quite. So Derek, let's go to you, and then. We do have, yes, that's what I was looking for here for this first one. Vertical angle at B, okay? So, but you need to name a little more specifically, right, Derek? So what's the three-letter name for this angle right here?
DBE.
DB. If we do DBE, we're talking about this angle. And that's not part of our triangle. Right? DBE is not part of one of our triangles.
DBA.
DBA must be congruent to...
ABC.
A, B, C would be talking about this angle. Oh, sorry, I didn't hear you. Maybe if you spoke in your normal voice, I would have heard it, understood it correctly. And that's vertical angles are congruent. Okay? Yes, Ike, a question.
So when you were coming around, you told me that I was right when I said segment DB is congruent to segment DB. Reason is because B is the midpoint.
That's true, but again, we already have it stated because it's part of the given information, so we don't need to restate it, is what I'm trying to say.
Yeah, but it never said B was the midpoint.
You're right.
Wait, Mr.
But because this is true, B is going to be the midpoint. It must be.
So, I mean, how is that not wrong then?
I'm not saying it's. It isn't wrong. It is
Okay.
correct, but it's not necessarily helpful. Is what I meant to
So
say.
why can't I put it as congruent?
Because it's already listed right here. It's already listed and given. You don't need to restate it. You're stating it doubly.
What's the vertical?
So, guys, remember vertical angles. Ramel and Maddie, guys, can you cut it out, please? Whatever you're doing there. Thank you. Thank you, Ramel. And then Derek, guys in the back, please. A vertical angle, right, are when two angles are opposite each other like this. And both of their sides, so this side of this angle is opposite from this side of this angle. And the other side for this angle is opposite to the other side for this angle. Their sides are complete opposites of each other, therefore those two angles must be congruent. They're equal. Right? We talked about vertical angles like way back. This was an earlier topic, so that's maybe why you forgot or something like that, okay? So that's where they're from. Now, speaking of going way back, our third congruence here, which Matt, I think, was kind of hinting at, and he maybe was on the right track there. If we have two parallel lines cut by a transversal, and we could say either line CD is a transversal that cuts across these two, or we could say that AE is a transversal that cuts across these two kind of parallel lines. We have some other angles here that we can name congruent based on that. So, for example, angle A must be congruent to what other angle? E. Okay? So we can say angle A is congruent to angle E.
How is it not congruent to C?
Hang on. Or, what other two could we say are congruent? C and D. Either one of those is acceptable because these two lines are parallel and they're crossed by a transversal. But why? What special angle pair are A and E? Or what special angle pair are C and D? They're the same kind. So they're alternate interior. They're alternate, I'm going to abbreviate that. Alternate interior angles are congruent. How do we know they're alternate interior? Because we have a parallel lines cut by a transversal. So that gives us these alternate interior angles here. And either one of those pair we can use. Yes, Ikeva.
But if you look at the shape, like, angle A is angle C.
Actually, I'm using E and A and E, so I'm going to use this one. Okay, sorry. What's that?
I said angle A is angle C, right?
So they're both at the top, but you have to realize that this triangle is not a reflection of this triangle. You have to like rotate this triangle around to get it. So see, A matches down here to this one because, again, look here, BD matches with this. And so it's not a reflection, it's you have to like rotate it around. So A really would match to E, D would match to C.
So will you show me like with the proof statement how to do that because I'm not a visual person.
So you, well, with the proof that I've stated it right here, basically, is what I'm trying to show you.
No,
Is that?
remember when like we would have a congruent statement and you would
Oh,
be like,
yes.
you have to pay attention to this because
Yes.
this doesn't work for you?
Yes. So it's right there.
I know, I'm saying like what
Oh, you want me to run through it for you? Yeah. So A is in the first position,
Okay.
and what does it match to? It must match to E. D, third position, must match to C.
So why can't you do I guess.
You see that? Okay. So we're finally done.
Why do you take out the angles of CD?
Because I chose to, because I don't need that many congruences. It's too much information, I think. Like, I decided to just use these three pieces instead of this third one. But either one of those would be acceptable, Zaria, but I would just say stick to one of them, because otherwise, well, You know what? You could do that if you wanted to, because then if you did that, you'd have a choice. But anyway, we're not going to worry about that right now. Okay. Triangle ABD is congruent to triangle EBC. And the reason for that is, well, what is the reason? Again, we got this. What is this, guys? Is it angle, side, angle? Angle, side, angle? It's angle, angle, side. Yeah, the side is not between the two congruent angles there. So there it is. Angle, angle, side. Okay? So, what I would like to do, okay, is to give you these on the back to try for yourselves, okay? You can start on any of the ones you want, but I would like you to try them. Okay, I'd like you to try all of them. Okay? So do all three, please. This is what I want you to work on. Okay? And I'll come around and help as necessary. So, Matt, yeah. You want, like, some real big help, right?